the stage. The thing that the world is changing. The world is not what it used to be yesterday. Many factors introducing the change, including technology. And this technology is actually driven by the explosion of data that is happening around us, by us, for us. At the same time, what is also happening is that the data is also impacting the economic patterns, the business patterns, people's life patterns. And therefore, we are at an inflection point in the technology journey where we want to harness this data to make the best use of us. Now, data, where is it coming from? Because this is the most, what is the most frequent activity that you do? You play sports, you eat, you walk, you run, you do work, you sleep. No matter what you are doing, you are generating data. That is the most frequent activity we all do. Even while sleeping, we're generating data. You know, the sleep trackers and how many hours did you sleep, whether did you have a sound sleep or not, did you change sites multiple times? They give you all the data. So even while we are sleeping, data never sleeps. And the important thing is that irrespective of what sphere of work you belong to, whether you are a teacher,
Definitely.
you are a real estate person, or you are a manager, you are a doctor, or you are a share broker, or you are a software engineer, you produce data. And all these data together is helping us to create more data, and to be able to make the best use of our business, our knowledge. It is important to use that. This is what happens in 1 minute. And this is like a mid 2023. So some of the numbers would have definitely gone up, especially the chat GPT, the visits, they must have definitely exploded in multiple factors. But you can see how many things happen. And this data is not I would say one-dimensional data. This is not just text or numbers. You can see videos. You can see pictures. This meeting is also data. So all these data together are being produced every minute in a very explosion format. You can see 1 minute on the clock is actually over 15,000 person hours for this world. You can imagine 15,000 people working for an hour. Is that's what this 1 minute is equivalent of? So you can no wonder humongous amount of data is being generated. Now, if the data is being generated, the data doesn't want to get generated where it is, whether it is your from your smartwatch, your computer, or your any server, and go sit in some cloud somewhere on a storage and have no meaning to the life. Just like we people, data also has a meaning to the life. Data has a desire, it has aspirations. It wants the data be used for a fruitful purpose. Data wants to be used in a way so that it can change people's life in a positive way. Data wants to be used in a way to make people's life fun. Now, don't let the data sit there and do nothing. Use it, chat with your data, have a conversation with your data, and make sense out of it. That's super important, because data is actually the one and zeros and bytes and bits representation of your life, of our business. So if we chat with it, we'll be able to get response answers from about our life, about our business, about many things. And you can actually make a transformation using the data, because we want every byte of data achieve its full potential. We don't want the byte of data just to be sitting idle doing nothing, because data has lots of potential. And but again, chatting with your data is not something new. People are having conversation with the data for a long time. Ever since structured data management has come into place, people are able to store and capture data. People have been able to give precise commands to the data in a very prescribed language, and the data will give back you very precise answers. You want to know, okay, uh, what was my business revenue in 2023, and you will get a very precise answer. Or give me my revenue for my business for last 5 years, you will get very precise data. But if you want to ask slightly vague questions, slightly imprecise questions, um, the the way the data is stored and manipulated by normal computing system is very hard to get you that kind of imprecise information. Imprecise information does not mean that they're irrelevant. Actually, imprecise information are sometimes more relevant than very precise information. I'll give an example. You may have heard about the joke. Is that somebody who was in a hot air balloon lost their way, and then while descending, asked a person on there, okay, like, "Oh, can you tell me where am I?" And the response they got, yeah, you are this latitude, this altitude, this longitude, etc., etc. You are in a hot air balloon, you are in a sunny day. So they gave all very precise information, but none of them was useful for the person in the hot air balloon because they wanted their way to a place where they can land their balloon. So this is the kind of thing. So you want sometimes ask imprecise questions and happy to get close enough answers because you can make meaning out of it. And that is where um, the modern technology is helping us to bridge this from imprecision to relevance. You can make this connection through intelligence. Today we do it through human intelligence. When somebody is asking you something and you answer them something, and they are able to get the relevance out of it. So you may ask, how far are you from work? Or if somebody is coming to visit you, you can ask, how far are you? And somebody say, okay, I'm about 15 minutes away, or I'm about 3 miles away, or something like that. And they'll able to make kind of sense out of it. You don't exactly have to keep that, okay, I'm 3.167 miles away, or I'm 23 minutes, 15 seconds away. You don't have to give a precise answer. Approximate answer is okay because intelligence can kind of make sense out of it. When you are dealing with humongous amounts of data and you want to use machines to make sense out of it, you want the machines to convert imprecision into relevance, artificial intelligence comes into picture. That's the one which is bridging the gap between these two worlds for us today. So with that, I want to bring out a few fundamental things because making sense out of data through machines has its responsibilities. And we at Microsoft, we run on trust, which means that your data is not our data. If when you are storing data in Microsoft Cloud, you are storing in a responsible, secure place of your dimension that you have chosen for security. And now what happens is that your data is used by you, nobody else. Your data from any fine tuning is not used to train our any of the models that we use at Microsoft. And at the same time, your data is protected by the most comprehensive enterprise compliance and security controls. And because we give a lot of stress to using AI responsibly. Responsible AI is a mandatory function for everything we do, from storage of data, from usage of data, to building AI models to give you the AI tools, the way you can operate with your model. Responsible AI is a fundamental principle of Microsoft because Microsoft runs on trust. I want to make this very clear because a lot of these things are super relevant in today's world. And with this, I hand over to Davide to take us through some of the key concepts that we'll use in our demos and so on. Davide,
Yeah.
feel free to share your screen and
Okay.
go from there.
Let me present in Teams. And here we go. Yes. PowerPoint is loading, and I will start from where you left off, which is here. Okay, so what we will be discussing today mainly is something called Retrieval Augmented Generation, which means that you want to search something, but again, since the search it's done using some approximate ways that better reflects what you normally do in life, but it may return imprecise data, right? So in order to make them precise, again, you need to have some context and some way to make sure that let's say you get 10 result, you only returns to me the 3 that applies to not only the search that I made, but also the context where I'm in, right? And to do that, you need a AI model, LLMs, and basically AI means in this case, or RAG in this case means that you will do some search using some similarity approach, some similarity technique, which means behind the scene using vectors. So that's why today the session is called Searching with Vectors in Azure SQL. And then you'll take the result, pass it to an LLM, which, even though they are very powerful today, they still have some limitations. So for example, you know that LLMs has a limitation in number of tokens, which is basically pieces of words that they can process. So you can't simply take the whole database that you have and send it to LLM. And even if you could, it will probably be super expensive, so you wouldn't do it anyway. What you normally do is do some similarity search in order to make sure that out of the million or 1,000 elements that you have in your database, you only find the one that are somehow similar to the topic of the search. And then you send the resulting document, maybe the top 50 or the top 10 or the top 100, you decide, to the LLMs. So you don't overflow the LLMs with additional data. You don't have to pay for more data that you need, and you don't even hit the limits that LLMs have today. So you send that data, that information retrieved with the vector similarity search to the LLMs, and then the LLMs can return you some meaningful information even in natural language. So that's what we are doing, and the basis of this approach are several concepts. Probably you're already familiar with prompts and prompts engineering. So in order to set the context I was discussing before, like, because we have at some point we'll have a bunch of data that are returned by our similarity source. So you have rows of data that are coming from your database. But how do you set the context? How do you explain the LLMs what to do? Well, you have to tell it just like you would tell to a human, like, please take this information and help me and behave so that you are, for example, operator helping me to decide what is the best combination of clothes for a wedding. Something like that. And I'm not kidding. You will really explain the AI, your goal and how it should behave to help you in the term I just described. So that is what is known as prompt engineering, and it's very important to do it right because still AI are computers or are based on computers. So you need to be very precise in what you want to get as an answer from the AI model. So we will be doing that, but before that, we also need a way to identify what are the topics that are related to our search. Not exactly, but somehow related. For example, if I'm asking for some information around what is the best let's say birthday gift for a boy. Well, first of all, I need to find in all the products that I have in my database, what are products that are somehow related to boys, what are related to birthdays, find the intersection, maybe do some additional filtering using the typical search that we already have today by category or by price. So doing what is called today a hybrid search, where you want to search for some, let's say, similarity concept, and at the same time, you also want to define the search within some very exact concept, like the total cost of what you want to spend, right? The ceiling is a very clear and fixed amount, for example. And to do the similarity search, you need to do something that is quite interesting, and you also need the help of AI here, because you want to take the concept and turn it into something that is mathematically manipulable, so that you can calculate how one concept is similar to another by just using calculation. The process of turning some human information into something that is manageable by a computer is called is said to get an embedding. So embeddings are representation of data in mathematical terms, and the mathematical terms are actually vectors. Vectors are arrays of numbers that represents something for the computer that is also tied to a human concept. Again, like cloth or a cake or a computer, they can all be converted into numbers by an AI model. And if you convert two different topics using the same AI model, then you can use the resulting vectors to calculate how distant or how similar those two concepts are. The more similar they have, the closer to zero they will be. So if you imagine that you are doing something like the difference. Actually, we will not be calculating the difference. We will be calculating something called cosine distance, which is the most common way today to find similarity between two vectors. So you will be basically calculating the cosine distance between these two vectors. The closest to zero, the most similar they are. So probably cake and birthday, they will be somehow similar. But I don't know, car and cloth, maybe they are not so similar. So the similarity will be close to zero, for example. The distance will be close to zero. So having said that, let's move to how we can really use this this information to basically build something, right? And so let's start with something very common. If you go to conferences, especially the big one like Build, like Pass, Ignite, or many of these big conferences, you know that there are hundred, if not sometimes thousands of sessions. And just searching what is the most relevant session for some topic you are interested in is actually a kind of a time-consuming process. So a good way to start to understand how AI can help to create better solution starting from vector similarity is really building a session recommender solution where you can add title and abstract of session, and then you can allow customers or users to search for a session that is similar to what they are interested in. Like, for example, GraphQL if they are developers, or databases, or API, or whatever concept they are interested in. And if you do this solution well, the architecture that you will come up with, it's something that can be reused for anything, not only for searching for similar session, but to search for similar products or similar recipes or similar whatever. Because the architecture will be exactly the same, only the source of data will change, but the entire process will be absolutely replicable in the same way. And that's exactly what we built in the last months. You have two options to use the architecture, the one that I will be showing today and the one that you can super easily deploy. And I will, you see the GitHub repository that you also can already have access to in a few minutes, is based completely on a serverless approach. I decided to favor this just because it was the easier to build and the one that I think it shows how cool Azure can be, or just so you basically write the code that you need to write and you leave all the infrastructure part to Azure. And here you have the core, of course, the SQL database, where it holds all the information about the session and the speakers and everyone. Then you have something called Data API Builder that allows to take a table, a view, or a stored procedure and immediately make it available as a GraphQL on REST endpoint. So you don't have to write code in order to make the database available to, for example, a JavaScript frontend. And then you have a JavaScript frontend. In my specific case, in the sample you will be seeing, we have written everything in React. So you will have a front-end application that is basically sending JSON back and forth to a set of backend API supported by Data API Builder. Data API Builder is also open source and can run both in Azure and on premises, so you are really free to use it wherever you want. And Data API Builder will actually connect to the database for you, exposing, in specific example, a storage procedure that allows you to do vector similarity search on the data. Now, of course, I said before, vector similarity search alone is not enough because we need to take the text that has been typed in the search box and turn it into embedding a vector. And to do that, you need to use OpenAI. Azure SQL has an option to call a REST endpoint, and luckily today all API, and thus also the OpenAI API, is exposed as a REST endpoint. So we will be able to call right from Azure SQL the API on OpenAI to take the text and turn it into a vector and get the result back. And then we can use the vector in SQL to do similarity search. Another interesting thing of this architecture is that you probably also want to make sure that as soon as in the backend you add a new title, a new abstract for a new session, that title and abstract is also immediately transformed into a vector, so that vector similarity search can be done, because of course you need to compare the search vector against the vector that represents your session that are stored in your database. So you need to transform the abstract and the title of your session into a vector too, and that should happen immediately as you add or update the session details. And that happens using an Azure function that is automatically triggered every time new data or data is updated in Azure SQL. And that happens thanks to something called an Azure function trigger. Is not a SQL trigger, I just want to highlight it, is a trigger in Azure Functions terminology, which means that you have an Azure function that is running behind the scene, and every time some data is inserted or updated or even deleted in a table that you want to monitor, that function will fire and execute your code. So this is pretty cool because it allows you, for example, in our case, to send the title and the abstract to OpenAI and send it back to Azure SQL. This architecture is something you can easily deploy in your Azure subscription if you prefer to have instead, like many developers prefer today, to have a containerized architecture where every single service is contained in a container and you're not using a serverless service because, let's say, you want to also execute what I just described fully on premises. Well, you can. You can basically take the same concept in, I would say, 90% of the same code and just run everything in a container, right? The same concept will apply no matter if you are using a serverless approach or a containerized architecture. Okay, time to go to
David,
the demo. Yep.
There is a small question, actually a good question in the chat. Can you please, it's a Kaveh ask it, can you please compare this approach to the Azure machine learning prompt flow at some point?
Yeah, we will do it before the end of the session, and Sanjay will show you prompt flow. We can discuss how to use it in the solution. Absolutely.
Awesome.
Cool.
One more point that I want to remind everyone, please use the chat for questions and discussion. Follow it because it's a user group. It's not just a lecture.
Yeah, absolutely. Okay, let me share my screen then, this one. And let me know if you can see my screen. It should be a nice, very long road. And I am now opening.
I can see it.
Perfect. Now I'm opening the .NET Conference 2003 website. Why I'm opening this website? Because if you go down below and you click on Find Session, you will be brought to this website, the .NET Conference Session Finder. This website is built exactly on the architecture I described before. So let me just say, for example, I want to search for GraphQL topics. So this will actually take the GraphQL data, send it to OpenAI, transform it in an embedding, and run similarity search on the session stored in the database. And as you can see, it's returning everything that is somehow similar to the GraphQL concept, which is a way to expose your API. And at some point, you will see, for example, also something that is related to GraphQL, but other stuff, right? So here you can really find anything. You can ask anything, like sessions on, let's say, AI and .NET. And as you can see, even if I type it in a sort of a natural language, since we are converting it to a vector and then comparing the concept represented by the vector, which is a session on AI and .NET, we can easily find, even without using an exact match, all the sessions that are somehow related to AI and .NET. So this is pretty cool, right? And this is exactly what you can build, and you can do it right now. If you click on the little GitHub icon, you will be brought to the Azure SQL DB Session Recommender repository, where you have the full example I described before. And the example, it's very easy to download and install because it uses a tool called AZD. Azure Developer CLI. It's an amazing tool that once you have installed it, the only thing you have to do is to initialize, unless you are already using it and you already have cloned the repository because you want to explore the code and everything, you can just initialize a local copy of the repository and then do AZD up, and it will create everything for you. Now, I already did it. It takes exactly 8 minutes to deploy everything. There's a lot of stuff that will be deployed and connected together. So here I can just do AZD show that it will connect to Azure and tell me exactly where my resources are and where I can find them. So here I have a function apps, the one that I told you that will automatically fire every time there is a new session added in the web application in the portal. So I will start from the portal because I think it's interesting to see what has been deployed, and then we'll start to play with vectors and everything else. So just to again get the details of the deployment, you have quite a lot of stuff here. You have the SQL database, you have the static web apps. So let's click on the static web apps. The static web apps is what holds the full end, the full stack application. So let me click here. And here we are. We have our cool conference session finder because, of course, I didn't want to use the same name I used for the .NET conference. So let's say you have a cool conference and you want to offer the ability to search for sessions to your users. Well, now we have 0 session. So we first of all need to add some session, right? So what we can do, and everything I'm showing right now is explained in the repository, in the README. I can just go to my SQL database, and again, if I go to the repository and there is some sample code, so let me copy this, go back to my database, I'm just using the query editor right now. It's quite easy to start with. Let me connect and continue as myself. And then what I want to do is simply insert into the table web session that holds title information. This is a oversimplified database model for storing session information, right? But the point is just to show you how to build a similarity search solution. So let me add those. And okay. And now what is happening behind the scene is that the function is being fired off and this text is sent to OpenAI to be converted into a vector. So let me show you the vector that has been stored in SQL. And we can do it by just doing select star from, and there is from the web dot session abstract embeddings. So here we go. Now, this is the session I just added, the session ID, and these are the vector. So all these values represents for that session ID, the vector that represents in AI model, the concept of what I typed as a title in a description. Now, with that vector, I can have a storage procedure that basically do the search. Now, before going to see the storage procedure in action, let me just refresh the page. Now you will see that there is one session here. And now let me search for GraphQL, for example, again. And you will see that the session is returned. Now, of course, obviously there is only one session, so it's obvious that it was able to find it. Let's add some other session right now. So let me add some other session. Let's go here. Let's stay in the portal. So I'm adding some sample text. So something completely unrelated to session, some session on Azure function, and let's see what happened. And in the meantime, let me, this is probably already done, right? Actually, if we go and take a look at the session, so let's say select from web.session. Now my session is have ID bigger than 10. So let's see, and I'm just taking a query already prepared. Let's see if the abstract, if the embeddings has been already fetched and retrieved and inserted in the database. Yes, you see that all my session have exactly 1536 values for each vector. That's the typical size of a vector returned by OpenAI for what concern embeddings. So everything is stored in SQL, great. So this means I can go here and say, well, there is any sample data now. And let's see what happens. Yeah, sample text, no GraphQL, because of course that doesn't have any relationship with what I wrote. And here the relationship is because I typed data, and so there is some similarity, right? If I just say show me the samples, you will see that only sample text and another sample text are returned and not GraphQL. If I want to see sessions on serverless, That is going to be interesting because serverless is not mentioned anywhere in any of my text. Still, the similarity was able to understand that Azure function is actually a serverless service, so it is returned as long as the session recommender, because here we are mentioning that we use API and everything, and so it's very likely to be somehow related to sessionless things. So this is pretty cool, I would say. Now let's see how it works behind the scene. Well, behind the scene, this is the repository that basically you will be able to download and deploy using AZD. The database is super simple. And the interesting part, I would say, is the story procedure find session. So find session will take the text, and then if we go a little bit down below, you will see that we use this story procedure called SP invoke external REST endpoint. This is the story procedure that allows us to take the text and call an OpenAI embedding model so that we can get the vector back. Then we take the vector and we open the vector and use its values, because a vector, as I said, is an array, so it's a set of ordered values. We use the vector to calculate something called the cosine distance, or cosine similarity specifically here. This calculation is simplified because the vector returned by OpenAI have some properties that allows us to simplify the calculation. And if you're interested in understanding what are store properties, you can follow this URL and understand all the mathematical aspects behind it. But basically what we are doing is really calculating a multiplication and a sum between the vector that I'm searching for and the vector I have stored in my database. And thanks to the fact that the vector is stored in a column store format, the performance are pretty fast. As you have seen, it takes less than an alpha second to return the data. And then, of course, once we have the similar vector, we just basically return the title and the abstract. So what we really want to do is take this story procedure that, again, internally even send a request to a REST endpoint, do some calculation, then return the similar vector, and expose it as an API so that it can be called by the front end. And to do that, you only need to use Data API Builder, which is basically a configuration file when deployed in static web apps, where you say, hey, I want to expose the story procedure web find session, and I want to expose it so that it will be available as an API named find related session. The API will be available both via GraphQL or via REST. That's all you need to do in order to take a story procedure or a table or a view and expose it as a REST endpoint or GraphQL endpoint so that your application can actually return the data. So let me actually show you. If we go with F12 here and do a search again, you will see that if I go in the network, here we go, find. So the endpoint called find has been executed. The payload was the text, and the response has been the result of the story procedure. Again, why REST find is the right endpoint to call? Because if I go to my configuration, you will see that REST, my story procedure, is exposed at the path find for my REST listener, and Data API Builder is listening on /REST. So if you do /REST/find, you will actually be calling a story procedure, which is exactly what is happening here. Okay. That's it. That's the basically the entire architecture deployed, and the fact that we can search for vector is, again, super easy. As shown before, it's really nothing more than doing some very simple math calculation and in Azure SQL using column store to speed up the search. Now, something I want to show right now is something funny. Let's go to the real data, the real website used for the conference. And of course, if you search for things that you expect to exist, let's say, of course, Maui. Yeah, you probably find everything that is related to that. But what if we search for something like fried chicken? Fried chicken. Well, interesting. That is unexpected, right? Because somehow the AI model that turns a concept into an embedding returned us vector that still have some kind of similarity between fried chicken and building cloud native apps with .NET 8. That's weird, right? That's a little bit weird. Why is it happening? Well, because of course, vector represents things that are similar in the AI model thoughts, but they are lacking of a context. So we need to provide that context using the prompt engineering and then moving to a proper retrieval augmented generation solution. So to do that, let's just switch gear a second. The concept is exactly similar, but instead of searching for session, let's try to search for products in e-commerce database. So here, what I did is I have created a table with a Walmart dataset. It's open source. You can go to Kaggle and download a reference Walmart dataset with all the reference e-commerce product from Walmart.com that has already details and titles. And what we did is convert everything into vector using OpenAI so that we can do something interesting. We can, for example, start to say, okay, I want to find all the products for organizing a birthday party for a teenager boy. So following the same approach we said before, now what we will be doing is take this text, convert into embeddings so that you can basically have a vector. And let's start from that point. We will just store the vector somewhere so you can see the vector. But the key point here is that from Azure SQL, we can call the storage procedure, right? We can call the, using the storage procedure, we can call the REST endpoint. Okay, this is the result. So it's very fast because we are just calling a REST endpoint. I passed my text, and this is what, in mathematical term, represents that concept for the embedding model I'm using. Fantastic. So what I can do right now is save the vector into a table, and then use the vector to search all the similar products. So get similar items is exactly the part that will do that. So this, again, is the vector. Fantastic. I just want to use the vector to do similarity search. So I'm taking the vector and, again, doing the simplified calculation for cosine similarity. And cosine similarity will actually let me execute this so we can discuss it together later. So first of all, you see, actually, let me just execute this one. You see, it's pretty fast, right? I'm searching for similar products across 30,000 products in this case. And for each product, I'm calculating how similar it is to the concept that I have expressed before, which is to find the best product for organizing a birthday party.
Hey, Davide.
Yeah.
Davide, I have a question.
Go for it, man.
Okay. I have a teenage girl.
Yeah.
Okay. So can we see if things change from a birthday party for a girl for birthday party for a boy?
Yeah, let's try. So for a teenager girl. Okay, let's save this. And now let me go to get similar items. I will skip this now, just directly go to the similarity search. And well, I don't see the Teenage Ninja Turtles right now, which is, I see Princess. So definitely something more, let's say, well, definitely suitable for my daughter, for example. She will definitely prefer Princess. And now we are returning 50 of these, right? And among these, there are a lot of stuff that is, decoration and other stuff. So what I asked is not just gift, is products to organize a birthday party, which include gift, includes decoration, include cakes, everything, right? How do I put all this product together given the context? How do I explain the context?
One interesting thing that I observe.
Yeah.
Is that, of course, the product at Walmart has the same product has a different size and different color.
Yeah. So you have more than one.
So the more than one, but also that this search is so, I would say, smart in a way that it picks the size for you as well. It picks the size for you. It picks a potential color for you as well. It could probably pick a different color depending on the input that you gave. Very interesting, very smart.
Absolutely. But we can make it even smarter, right? Because here we would probably have the same problem I showed before. Like we can search for something completely unrelated and still find something, right? Instead, I think we had this discussion weeks ago, how we can make sure that we only return something that is appropriate given not only the search, but also the context. So this is what, and for example, in the sample of the session, how do I say, hey, there are no session on fried chicken at a .NET conference? Yeah, there is something similar, but you don't really want to go to the session on .NET if you are really interested in fried chicken, right? So how we can apply the same concept here to make sure that we can have an AI helping us not only to limit the products to the one that are interesting, but in general to get a more correct and human answer. Well, so now we have all these 50 products here that are somehow related to what we are searching. And what I will be doing right now, and this is the interesting part, I will be, and here I have to change, we said girl. So how we change, how we use that information so that I can ask like a consultant out of this product, what you would recommend. So I have to connect to my OpenAI LLMs, in this case, not the embeddings model, but a proper LLM model, and specify, hey, you should play this role. You should be an system assistant that help user to find ideas, to organize birthday parties, blah, 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 using the product provided for you. How do I provide the product to you? Well, I will give you a list of product with this format so you understand what is the ID, what is the product title, what is the description. What I want you to do is answer to what the customer is asking, which is just the text that I used also to do the vector search. But please returns to me something that is manageable by an application. I want to have a JSON that contains one property called answer, where you tell me the answer, at least a products property with the array, so a comma separated list of the products ID you have picked to answer me, and why you made the decision, because I want to understand why you did that. So what we are doing here is taking the product that we have found with the vector search, aggregating it so that the whole payload can be sent into this bigger payload that we will be sending to ChatGPT-4. So before we use the AI to turn text to embeddings, to vector, now we are using AI to take the text and understand it in quotes, and so that it can return us the result. This will take a few seconds, but let's see. Oh, I have to rerun this most likely. Yes, so let me run this, and now what is happening is this. Oh, sorry, I forgot get similar items. Here we go. Nice, and then I can go chat with data, and fantastic. Okay, so this will take, if I remember correctly, something between 10 seconds, but the answer will be honestly amazing.
So now this is great time if we have 10 seconds for 2 questions.
Yeah.
First of all, there was a question if by the embedding model you mean text embedding ADA.
That's right. ADA 2. Yes, that's right. That's what we are using right now. Yes.
The second question is actually mine. It's more to confirm because I have done it in a bit different way. You are using the SP invoke external REST endpoint. This is used for Azure database.
That's right.
But you can do exactly the same with the SP execute external script, and then you can use local server as well as the managed instance. So I just want to confirm that it will be exactly the same.
Yeah, so since I'm using Azure SQL Database, I'm using SP invoke external REST endpoint to call a REST endpoint. If you're using MI or on premises, you can use or SQL CLR or SP invoke external script to do basically the same. Absolutely, yes.
Okay, I added it in the chat for people if they want it.
So here I copied the answer that AI model told me. So here we go. For a teenage girl birthday party, you can consider following products. You know, woodland fairy large invitation to set the theme for the party, dress up the birthday girl with the birthday, and blah 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 blah. So very specific and human-like answer based on the product I have in my database, or I have picked maybe using a vector search, or I have added myself because let's say I want to absolutely have a product to give to my birthday girl, right? Now, the interesting part is that the result came as a JSON format, right? Because that's what I was asked, what I asked. So here I also have the comma separated list of product. So imagine building an e-commerce where you already put the product for me in the basket, or you prepare to me a bouquet with all the possible combination of this product and maybe other products, and then the reasoning behind, like why AI recommended this product and gave this answer. I said, I consider product that will be suitable for a teenage girl birthday party. I selected product that would set a fun and festive atmosphere, like decoration and tablecloth, and so on and so forth. So it's very interesting, right? Now, everything I did, just imagine adding it to your application. Again, and we can do it also for the session. We are actually building a version where you can chat with your session. But now you see that the same principle can be applied to everything. I apply the principle of the session to a product. Now I can do the RAG solution that I built for the products. I can apply it back to the session or anything else. And to just give you a sense of how this would work together, there is no need to have several scripts and everything. Let's try something completely different. Let's say that I am, again, building a online e-commerce, and people will ask me, show me the best product for cleaning a kitchen. Yeah, let's run this. And now I can just run in one script. Of course, you may want to maybe do something. I'm doing everything in SQL just to show you that even if you have an old application, you can still modernize it. If you are building an application from scratch, you may probably want to split some of the logic between SQL and maybe C# code or Python code, for example, for specifically calling the LLMs. But here we go. For clean the kitchen, you can use blah, blah, blah. So let me copy this here. And again, we are doing a search on my database and then passing everything to LLM. Now imagine a more complex scenario, right? And then I'll hand over to conclude and hand over to Sanjay. Imagine that you also want to put some constraint in the product, like I don't want to use a product that pollute too much. So you can start to filter out product using the typical approach to filtering that a relational database has, and that will actually speed up also your query even more, because you will first use an exact search and then move to a hybrid search and a vector search, and then move to LLMs.
Hey, Davide, sorry, somebody has a hand up for a while, I guess.
Oh, sorry, I'm not seeing it. Thank you.
Yeah, Shiva, please, can you please go ahead and ask your question?
I already asked her to use the chat for the questions, so maybe it was a mistake of raising the hand. I will put it down. There are two questions if you already stop. One is very good question. The other one as well, but one I really like. Let me just find it. Okay. The first question, in the JSON format from the customer, does the answer product and thought need to be aligned?
Sorry. Yes. Yeah, that's. I need to replicate the questions both when I was searching the vectors and when I did the OpenAI call, because I had two different scripts, because I wanted just for demo purposes I split the script in different sessions. So that's why. But in the last script, let me share again the screen. Everything is just in one. Here we go. Everything is in just one variable that you don't have to repeat. Of course, it's recommended that you use the same text both for doing the vector search and the LLM search, because if you search for product that helps you to clean the kitchen, and then you ask what products I can use to do a birthday party, well, it's like I give you only 10 products that allows you only to clean the kitchen, and then I ask you to organize a party. I'm giving you a hard time, right? So we want to be friendly also with AI, not only with people, and try to give them the products that are really applicable. Otherwise, you may even get the answer, there are nothing here that I can use to organize a birthday party, right?
Okay, the second question that we have, I really like because I want to hear the answer as well. The question is, how do you evaluate the accuracy of the result at the scale?
Well, right now we are using the ADA2 model, which we know already have a good accuracy. But if you really want to, let's say, test a new model or test another metric function instead of cosine distance, you have to measure what is called recall, which is basically, let's say that you expect to have 10 answers when you search for something. How many of those 10 answers are you actually getting back? If your model returns to you exactly the 10 answers you are expecting, great, you have 100% recall, which is the best one. Otherwise, you would get lower recall, which means you may not receive all the answers that you should have received. And this is done because this does not happen with this specific example I did, because here, since the SQL is fast enough for the amount of product we are using, we are not using approximate search. Here we are using always exact search, which means our recall is always 100%. The moment we will add an index and start to trade off between speed and accuracy, that's the moment when you have to start to look for the recall and decide if you want to have faster answer, but potentially less precise result, or slower answer, but absolutely more correct result. That's a trade-off that you have to make with vector search.
Okay, so basically this demo does not use this feature, but we can add it if we want.
There is no approximate search supported in SQL today, so you can build it on your own. But since the question was in general how to measure the quality of the answer, right? For SQL, with what I'm presenting and what you can do right now, it's always 100%. So you always get exact result.
Okay, thanks.
So it's not only correct, but it's also complete. That means we have adjusted the entire data set. There is no other answer that will contribute to this.
That's right.
On the other hand, when you're doing approximate search, you kind of limit your search at, okay, give me the 5 and I'm okay with that. The top 5, I'm okay with that. I don't need to go look at anything else.
Yeah. And I think I'm done with that. Sanjay, if you want to take over and show the prompt flow, then we can conclude.
Yeah, we do have another maybe 11 minutes, right?
Yeah, that's right. Yeah, it was 75 minutes, right, Ronan?
No, not accurate. I said it in the beginning. Usually when I open the session, I emphasize this more. This is a user group. It's not a fixed time, and it's not a conference. Cool. Feel free to continue if there are questions. It's a user group. It's a meeting.
Oh, fantastic. But yeah, I have a hard stop at 10:15 though. So, but I'll go quickly and show something because there was an interest on prompt flow. So what is happening with all these LLM and technology advancements is that we are asking questions to data. When we are asking questions to data, we are we want to ask it in a way, even though the actual language is we're trying to ask the question in natural language, but there is a way to make this language more understandable by the LLM and give you the more accurate answer that you. And this is the prompt. So that if your prompt is well formed, you get a good answer. Maybe the prompt is something that is I would say. If your prompt is not so great, then you may get some kind of a nearby answer. So therefore, prompt is super important thing. As a result, a new discipline of software engineering is evolving is prompt engineering. So people wants to write the correct type of prompts, may take into account the context of the question, take into account the context of the structure of the data to help you write the prompt. So what Microsoft has in its AI Studio is something called a prompt flow. And the example that I'm showing you is that the prompt flow is now working against AdventureWorks dataset, which you all are very familiar with, and it is actually using it's a video I'll play, but I'll talk through. There is no audio. So what we have is that you are able to get the product information, customer information, and many other information from your data in a visual way through the prompt flow. And guess what? Combine that with the previous chat that you may have if you have stored your previous chat information, and help you along with the Python code to be able to actually write the correct prompt and a very effective prompt to ask the right questions to the LLM. And this can actually help your productivity, give you a visual way to understand the structure of your data, and help you, for example, these things like product ID, product management, and all this stuff. Super important to be able to pass it on your prompt. Then the LLM understand. Now with that, you will be able to ask these questions. You're chatting with the data on the right side in the same screen. This is basically a development and validation environment for you. You can have a visual, you can have a code, and at the same time you can have your chat. So that way you'll be able to get the kind of a questions that you are asking, and with the context, and to get that. So prompt flow is a super useful tool. There is a question about what is the way you are doing here versus the way you are doing in the prompt flow. So thing is that there are multiple ways to do things. Every developer uses their familiar tools, uses the tools they're most comfortable with, and uses the medium they're most comfortable with, the programming language they're most comfortable with. As you see here, this is a Python code along with quote unquote a structured representation of your data and schema, and then you are having a conversation. It is creating a prompt for you. Some folks are very comfortable with writing their own prompt and using T-SQL to be able to do the chat. Some people will be able to do it in a slightly different way. But the purpose of this tool is to improve your productivity as somebody who builds the prompt and scale. And that's what it is. And it is very context aware. And that's one of the other things that you need to be aware of, which helps you. So with that, we have about 5 minutes remaining in the scheduled call. Maybe Davide, we open up for questions, take questions on the screen, and then so on.
Yeah, I'm answering right now. I just want to highlight one of the answer to one of the questions that was asked at the beginning, how prompt flow played the role into all this architecture. Well, basically, you have seen in my demo that I actually constructed the prompt in the SQL stored procedure in my case, but it could have been in a C# code. The problem is that if you do that, is like you are putting the prompt in your application. If for any reason you want to change the prompt, you need to redeploy the application, which might be a little bit too strong as an option, right? So you probably want to abstract the prompt from the application itself. So that's why you need prompt flow. You can simply create an endpoint that construct the prompts, and then you call that endpoint from an application. Again, for the sake of the demo, in order to show the entire end-to-end solution with just one language, T-SQL in my case, so that it's easier to understand all the steps, I did everything in SQL. In a more practical solution, unless you have a specific requirement for which you need to do everything in SQL, for example, for security purposes, you probably want to use different tools for different jobs. Again, prompt flow is definitely one that I would recommend to use for a bigger solution. For a solution like, for example, the session recommender, honestly, the prompt flow is probably overkill, because again, you have to balance between simplicity and the complexity of architecture. If you are just building a session recommender, probably a prompt flow is overkill. If you are building a website where you want to sell products and provide the most accurate response to what customer answer, because that drives your your sales, you probably want to use a prompt flow. Hope that this makes sense.
I've just opened the option to use camera to everyone. You can use your microphone if there are more questions, and feel free to open your camera.
Hello, this is Shiva. I have a quick question on the cost. So whatever you have done, if I like to try it out on my end, like cloning the repository, is it possible?
Yeah.
Yeah. Is it possible for me to know the costs as I am trying to do that in Azure, or is it after the fact I can get a bill with a huge amount?
Yeah, I understand. So the repository is built. Let me share quickly my screen again. Is built to use the list of the costs that you can sustain. So, for example, where is the? Sorry, I have too many windows open. Okay, share this one. So this is what is deployed. Okay. So Azure Function is free up to 1 million requests. You can use even a free version of SQL Database if you want today. I don't think the repository is using it because when we created the repository, it was not available at the time. Probably we should update it, but you can have even a free SQL tier. I'm not sure about Key Vault. In the cognitive services, there is a S0 that I think is also free. So this should be pretty much, I wouldn't say free, but very close. I don't know, to answer specific to your question, if there is a way to know the cost upfront before deploying everything. I'm not sure. So
yeah, that's fair enough. Thank you. And
yeah.
Can you share the repo?
Oh yeah, of course. It will be on the slide, but I can share it right away in the chat.
I joined over my phone. Somehow it's not letting me chat.
No worry.
So
yeah, it will be shared in the slide.
After the meeting, I will ask Davide to send me all the session materials links, and we will share it at the same place that we share the recording. So just follow us. We share the recording. Usually in the comment, the first comment, I will add the session materials.
Okay. Thank you. And when you say the comments, is it in the meetup or?
No, in social media, in LinkedIn, Facebook, you can follow me or Jen. You can follow the official channel as well, the website, but the fastest is because the minute that I share the recording, I put in my Facebook or LinkedIn, I put the link. So this is the fastest way to do it. And then in the first comment, I put a link to the social materials.
Okay, thanks, Ronan. I'm just making sure I'm following you in the LinkedIn. Yeah. Thank you. This is really helpful because this is more like a deployed application rather than just some training stuff going through. I was playing with some LLMs too, but I'm using LangChain and things to do the prompt engineering. Like you can switch the models because that framework is giving more flexibility for selection of models. However, since I'm trying it on my personal tiers in AWS, I'm worried about the costs. Of course. Lambda and Azure functions are not expensive, but other things like deploying a vector database or things like that.
I will give you a small tip. I'm doing almost everything like this free. Instead of using Azure function, which cost, you can use Azure Logic Apps, which is free.
So running Azure function up to 1 million requests per month are free.
Okay, I wasn't sure about this. Logic Apps is the same. It's for there is a specific number that you can use for free. I'm using Logic Apps for the same.
Logic Apps, okay. I haven't tried Logic Apps yet. Is it an Azure offering?
Yes. One of our goals in this session was to give you how we can do this from your favorite product SQL. and you can have a free Azure SQL. As you know, we have a free offering right now, and get all these things, because if your data is already in SQL, look no further. You can call all these from within SQL, and you saw the Walmart example that Davide showed. It was all in T-SQL, all in Azure Data Studio, to be able to show you how you can use all these capability from SQL itself.
Yeah.
Okay. So thank you, folks. I need to drop off at this time. Thank you for having us here. Great conversation, and always feel free to reach out to us if any questions, feedback, concerns.
Thanks a lot for joining us. It was really great session. Don't forget, okay, he left us. So David, I will give you the information. Don't forget to register as speaker for the next Future Data Driven Summit 2024. Absolutely. Those are exactly the sessions that we want to have there.
Okay, thanks so much, everyone.
Thanks a lot for joining us, and a great session. Thanks a lot, everyone, for joining us.
Thanks, David, and that was outstanding. So we hope to have you next year, man.
Yeah, absolutely, absolutely. With some news around the vectors and stuff in SQL for sure.
Yes, and if there is anything new during this year popping up, feel free to let us know. We'll be happy to schedule you.
Absolutely. Thanks again. I have to jump.
Thanks.
Bye-bye.
Bye-bye.
Bye-bye. We'll close the session now, the recording. Have a great day, everyone.
Have a good day, everyone. Have a good day, and we'll keep in touch, okay? Thanks. Bye.